resume. Now I'm resuming. Okay, so that's fine. Everything else I'll pick up, I'll record. Okay, it's hard to keep track of all of this stuff, all this technology at the same time, I think, sometimes. Okay, so the next thing you want to know on like number 4 is I give you a point, and you got to know the trig function. So you have to know these definitions. You have to know that sine is y over r, cosine is x over r, secant is r over x, tangent is y over x, cosecant is r over y, cotangent's x over y. So that's your job, is to make sure that you have those things memorized, because I don't give those things to you. Okay, so in this problem, since I gave you the point -3, 4, I've given you that x is -3, and I've given you y is 4. Okay, so what I would have now is I got to find r. So the relationship between x, y, and r comes from the Pythagorean theorem. So if I give you x and y, which I do in a point, you also got to find r. Okay, so we would have to work out -3 squared plus 4 squared. So that would be r squared is 9 plus 16. That would be r squared equals 25. Then if you square root both sides, you're going to get r equals 5. So in this problem, you have x is -3, y is 4, r is 5. Now all you got to do is just put those in the definition to get your answers. Reduce fractions if you have to. So the sign is 4 over 5. Okay, the cosine is x over r, so that's -3 over 5. The secant is r over x, so that would be 5 over -3. I just need to have a negative somewhere. It doesn't matter where the negative is. The cosecant is r over y, so that will be 5 over 4. The tangent's y over x, so that will be 4 over -3, or just -4/3. The cotangent is x over y, so that's -3 over 4. So if I give you a point, you want to be able to take any point that I give you and find the 6 trig functions on that. Okay, the whole key on that is knowing these definitions of each trig function. Okay, does anybody have a question about what I did? Okay, are we okay? Say something or give me a thumbs up. All you got to do is put a little thumbs up there, so I don't want to feel like I'm teaching to nobody. Because I can't see anybody's face. You don't have to have your camera on while I'm doing this. So Jordan's okay. How about the rest of you? Are we okay?
I'm good.
Tristan, you're okay? All right, very good. Okay. All right. So the next thing is similar, is I'm giving you a trig function, and I'm giving you that the cosine of beta is greater than 0. We need to find the remaining trig functions. So again, this is an exercise in checking that you understand the definition. So the sine is y over r, the cosine's x over r, secant is r over x, tangent is y over x, cotangent's x over y. So if you know that, then you're in good shape to start with. So since I gave you that the cosecant of beta is -5/2, the definition of cosecant is r over y. So that means r has to be 5. Now r is always positive. So r is a radius, so it's always positive. And then y would be -2. So you got to know that that negative belongs to the y. R can never be negative, so that's an important fundamental fact. Now we know that x squared plus y squared is equal to r squared, so we need to go ahead and just plug in on this. We'll have x squared plus -2 squared is equal to 5 squared. Okay, so we can solve this equation. So we have x squared plus 4 is equal to 25. You can subtract 4 from both sides. You're going to get x squared equals 21. Then you can do the square root of both sides, and we have to figure out if it's plus or minus. Now, I think, Tristan, when I was talking to you today during office hours, I think this is the one I had a mistake on, and I didn't have time to correct that. So what you have on this, the way I like to look at this problem is like this. Okay, I've given you that the cosecant is negative. The cosecant's r over y. So if the cosecant's negative, then you have to be either in quadrant 4 or you have to be in quadrant 3, because that's where y is negative. I also gave you the cosine of beta is positive, and the cosine is x over r. So r is positive to begin with, x is positive over here. So I'll put like a different colored check mark. This is just the way I like to do that, okay? This is where cosine is positive, and these other two places is where cosecant's negative. So this means you're in quadrant 4, and in quadrant 4, x is positive. Okay, so what we have in this problem then is we have these three things that we have to know. Okay, we now know x, y, and r, and if you can correctly figure out x, y, and r, then it's easy to finish up the problem. Okay, so does anybody have a question about how I figured out x, y, and r? That's what I've done so far. Are we good with that?
Would this be one of those cases? Would this be one of those cases where all students take cash?
Yes, you could do that too. Okay, you can do.
Okay.
You can do that. I think I did. What's the one I put in my video? I can't remember. All students take calculus. Okay, there's that one. Okay.
Yeah.
So you can do that. And so now the sine is y over r. So that's just going to be negative 2/5 will be your answer. Okay. The secant is r over x. So that will be 5 over the square root of 21. And you don't have to rationalize. So that's okay. Tangent's y over x. So that will be negative 2 over the square root of 21. The cosine's x over r, so that will be square root of 21 over 5. And then the cotangent's x over y, so that will be square root of 21 over negative 2. And it doesn't matter where the negative is. It's okay if you write it that way. Okay, so the problem 4 and 5 are testing the same thing. Okay, it's can you take the given information and figure out the trig functions that are remaining on number 5. Okay, does everybody feel okay with what I did there? Okay, all right, so just make sure that you know those definitions of the trig functions. That's super important. Okay, the thing that students mess up on these problems sometimes is just not figuring out what quadrant you're in. So it's important that you understand what quadrant you're in, and you're always going to be in just one quadrant. Otherwise, you couldn't finish the problem. Okay, so let me go through a couple of things that pop up on this next problem and just show you a couple of things. The idea on this is we have some trig function, and we need to put this in a factored form and figure out the period, the amplitude, the phase shift, and that kind of thing like that. So the way it typically goes, you could either have a sine or a cosine. It doesn't matter. So it kind of goes like this. You have a general form, a factored out form going like this. I'll put b there. I'll put x minus c there. I'll put a there. And then I'll put like an extra number like this. These are how the transformations work. So this thing gives you the amplitude. The amplitude is the absolute value of a. Amplitude is that number in front of the cosine or sine. The b gives you the period. We have a formula that the period, and this is for a sine and cosine, is 2 pi over the absolute value of b. Okay, again, I don't give you that formula. You need to know that formula. Okay, the c, if you're in a factored form, is called the phase shift. Okay, and then this thing right here just means that you're either going up or you're going down. It's kind of like just moving the graph up d units or down d units like that. So what you want to do with this one is put this in a factored form first of all. So what I'm going to do is just write this as y equals negative 2/3 cosine, and you're going to factor out whatever is in front of x. In this case, 3 pi is in front of x. So that's what has to get factored out of there. Okay, and there's a couple of ways you can learn to do this. You're going to bring that down, and then you still got the plus 3, so it goes like this. Now, you can do it in your head, or you can do this. If you're trying to factor 3 pi x minus 6 pi, so if you divide each piece by that common factor, that'll tell you what goes inside of the parentheses. So that's just going to be x. This part right here is going to be minus 2. Okay, and then again, you can do a distributive property in your head to make sure it checks. So you have 3 pi x minus 6 like that. So we've got everything we need in the factored form. Okay, if I don't put it in the factored form, then it's important to get the factored form enabled in order to find the phase shift. Okay, so here's how this goes. This part is your amplitude. So the amplitude is always the absolute value of that number. So that's 2/3. Okay, that's how you get that. Okay, the period comes from this. When you do the period, you do 2 pi over absolute value of b. B is that number that's in front of x. Okay, that's the coefficient of x. So when you do the period, you will do 2 pi divided by 3 pi, making sure that that 3 pi is a positive number. And then the pi's cross out, so you would end up with a period of 2/3 also, just coincidentally. Okay, the phase shift is this number right here. Okay, and like when you were in college algebra, you learned that if it's minus, it goes to the right. If it's plus, it goes to the left. So since this is minus, this goes to the right. So you're going to have a phase shift. You just want to say right too. So I want you to either say left or right. Okay, and that will be your phase shift. And then this thing will be the vertical translation. And what that's doing is just, it's making the y values get bigger by 3. So this is taking you up 3 units. Okay, if that was minus 3, it would be down 3 like that. If you had a pretty good college algebra background and learned about graphing and about all of the transformations, it's the same on this. We just give special name to the phase shift, and then the period comes from that number and the amplitude. So you're learning a little bit of vocabulary on that. So this is kind of a good thing to study and make sure you have down. So if you're given a sine or cosine, that's how you figure out phase shift, period, amplitude, and vertical translation. Okay, does anybody have a question about that? Okay, trigonometry is a class. It's one of the math classes where you have to memorize a little more information than you do in other math classes. And so that's one of the things that you want to be aware of. Okay. The next problem on here is we're just kind of looking at figuring out range and domain of different trigonometric functions on this. Okay. So this one right here, it's helpful to know what the graph of tangent x looks like. Okay. So the idea is a tangent graph. Okay, and I'm not going to write this out perfectly, but a tangent graph has vertical asymptotes, and the graph kind of looks like this. Okay, that's the basic structure of a tangent graph. So you want to know the basic structure of each of the trig functions. So that range, the range is the y values. The y values go on forever in both directions. So it's going to go to infinity, and it's going to go down to negative infinity. And if I'm asking for a range, I'm asking for how the y values are ranging. So if you have a cotangent, it's the same thing. Okay, a quick review of the cotangent graph goes like this. A cotangent graph, you have asymptotes. This is all that you don't really have to know where the asymptotes are on this problem, but the graph looks like that. So cotangent and tangent graphs are pretty similar the way they look. So it would be the same thing. You are ranging from negative infinity to positive infinity like that. You can memorize these things, but the best way to do this is to memorize just what in your head what the graph looks like. Okay. Okay, now let me remind you of kind of what a secant graph looks like. Okay, so if you've got a secant, what you have on this is the graph of a secant is based on the graph of a cosine. And when you're doing a cosine, the cosine graph looks like this. Okay, you want to memorize what the cosine graph looks like, but so that you don't have to spend a lot of time on it. So the cosine starts at the point 0, 1. Then it cycles through these 5 key points. That's your starting point. That would go to 0. That would go to -1. And it's going to cycle like that forever. That is what we would call one period of that. And again, you could continue the wave over and over again, kind of like that. Okay. So what happens on a secant is these points that I'm highlighting in yellow, those are called the midpoints, and you're going to have vertical asymptotes. Okay, and again, all we got to do is just understand what the structure of the graph of secant looks like. So it's kind of like that, and then what you're going to have on this is the graph of a cosecant is just like these U shapes that set, one of them kind of sets on the top, one of them kind of sags from the bottom. So that's roughly what a secant graph looks like. Okay, so its range is going to be, this part here is going from 1 to infinity. It's 1 and above. And then this part right here is going to go from negative infinity to -1 like that. So the range of a secant, you can memorize it or you can figure out, understand how the graph goes. So that is negative infinity to -1, including -1, and then 1 to infinity like that. Okay. And the cosecant is the same. The secant and cosecant have the same range because the graphs are very similar. Okay, so we got that. So you want to know those things right there. Just know the range of all of the trig functions. Okay. All right. Now the next one says, what is the range of a sine and cosine? A sine and cosine always have a maximum at 1, and they have a minimum at -1. So the range of sine and cosine is going to be bracket -1, 1 like that. Okay, so that's what that's going to be then. Okay. All right, let's see. So the domain of sine and cosine is going to be all real numbers. Okay, there's no asymptotes. The sine and cosine have that wave that goes on in both directions forever, so its domain is all real numbers. Okay, so that's how you can figure that out. Okay, let me show you how to do this last one here. You have to do a little arithmetic problem on this. So what you have here is you have y equals 3 cosine x plus 5. So it's going to kind of go like this. The range of a cosine is -1 to 1. Okay, so we know that if it's just a cosine, it ranges -1 to 1. But the amplitude becomes 3 and it moves everything up 5. So what you do is you just do this arithmetic problem. You do 3 times -1 plus 5, and then you do 3 times 1 plus 5. And that will tell you where the max and min change to. So this would be 2. This would end up being 8. So that means the range on this is going from 2 to 8. Okay, so you just understand the fact that the range of cosine is -1 to 1, and then you can use that to figure out the range of the transform function. Okay, so you want to make sure you know how to do those kind of things. You can memorize the range of all 6 trig functions if you want to, or you can reason out what it is by memorizing what the graphs look like. Okay, all right. Let me look at number 8. And there's a couple of ways you can do this. I think the easiest way for most students, I don't remember what our textbook did, but the one I usually teach is all students take calculus. That's kind of the most common mnemonic device that tends to be in most textbooks. And all you got to remember is the A, the S, the T, and the C and what they mean. So this is a quick way to figure out whether the trig function is positive or negative. So if you're in quadrant 1, every trig function is positive. Okay, so you're going to have that if you're in quadrant 1. Okay, you go to quadrant 2, the S stands for the sign. So the sign is positive. The cosecant is also positive because they're reciprocals of each other. So if the sign's positive, so is the cosecant. And then everything else is negative. So the S just tells you the sine and cosecant are positive. Okay, the T stands for tangent. So that would mean if you're in quadrant 3, then the tangent is positive and the cotangent's positive. Everything else is negative. Okay, and then the last quadrant, if you go to quadrant 4, the C for calculus stands for cosine. So that means the cosine and its reciprocal, the secant, are positive. Everything else is negative. So I have you do that same kind of problem on the exam, but you can memorize it, or you can learn something like all students take calculus, one of those mnemonics like that. That's how you do that. Okay? Any question on that?
No, good.
Okay, now Tristan, I saw you typed a question that said, do you want right 2 or like my math lab plus 2? Either one is the same. I don't care which one. I prefer that you just say right or left. Okay, I mean, what they probably do in my math lab is like if it's left, they probably want you to put a -2 in. That doesn't matter to me. I just want to know what the transformation is and whether it's right or left. Okay,
okay. Thank you.
That's the number one thing. Okay. Okay. All right. So now let's go kind of to the next thing here. Okay. Now you have what we call cofunction identities. Now, let me go back all the way up to the formulas that I'm going to give you on the test. At the very beginning of this, I showed you there's some formulas I'm going to give you. So I'm going to make a copy, or try to anyway, of this thing right here. Okay, so now let me move this down here, because these things you don't have to memorize. But if you understand how cofunctions work, then it's a lot easier to do than just kind of referring to the formula to me. So the cofunction identities go like this. You've got the sine and cosine are cofunctions. The secant and cosecant are cofunctions. And the tangent and cotangent are functions. And you always find the other one by subtracting from 90 degrees or pi, or pi over 2. So with this problem right here, all you have to know on this, you don't have to really look at these identities unless you feel like that's the only way you understand it well. I do this, okay? The cofunction is the cosine. You don't have to memorize it. Sine, cosine. The co is why it's a cofunction. And then you just do 90 degrees minus 25. And you have to do that in that order. So you would end up getting the cosine of, and that would be 60, not 65, that would be 55 degrees like that, okay? Because, again, what happens is 55 plus 25, oh, I didn't do that right, it's 65. Okay, I'm sorry, I'm not doing that right in my head. So that's 65 degrees. So 65 plus 25, the two angles should always add up to 90 if you do this right. So that's 90 degrees. So that would be the answer to that problem, is like that. Okay. The next one, I give you a cotangent. So the cofunction of a cotangent is a tangent. Now, you could convert that to degrees. I wouldn't bother. Just do pi over 2 minus what I gave you, which is 2 pi over 7. Okay, get a common denominator is what you want to do. Okay, so common denominator is 14. So you can multiply this by 7 over 7. You can multiply this one by 2 over 2. And what you would end up having here is you would have tangent of 7 pi over 14 minus 4 pi over 14. And then you can put the answer together. So you would get the tangent of 3 pi over 14. Okay, so that's how you do a cofunction. Doing cofunctions is a pretty easy thing to do. You just got to remember that the other one is found by doing 90 degrees minus the given angle, or if you're in radians, you do pi over 2 minus the given angle. Okay, does anybody have any problem with that? Are we good with what I just did? Okay. All right, so it kind of works like that. Here's one other example. Like if I gave you the secant of 20 degrees, this would be the cosecant of 90 minus 20. Okay, so that would be the cosecant of 7. Those are pretty simple to do. Okay, next thing that we want to know is the right triangle definitions of trig functions. We haven't learned how to solve right triangle trigonometry problems yet. So in terms of opposite, adjacent, and hypotenuse, you want to memorize this. So the sine is opposite over hypotenuse. The cosine is adjacent over hypotenuse. The tangent is opposite over adjacent. And the most common way to teach students this is the SOHCAHTOA thing. Okay, so you have, it kind of goes like this. So SOHCAHTOA, that gives you the sine, the cosine, and the tangent. Okay. Then you have reciprocals. The cosecant is the reciprocal of the sine, so it's hypotenuse over opposite. The cotangent is the reciprocal of tangent, so that's adjacent over opposite. The secant is the reciprocal of cosine, so that's hypotenuse over adjacent. So again, these are things you have to memorize, and the reason you do because in trig you use those definitions all the time, and that's fundamental to trig, is to knowing those definitions. So in this particular problem, what I've given you is a right triangle here. So you would want to figure out what the three sides of this are, and this is Pythagorean theorem. So the way that a right triangle goes, the naming convention is basically like this. We always use C for the right angle. The side opposite is lowercase c. The other angles are A and B. Those are the acute angles. So opposite A is lowercase a. Opposite B is lowercase b. Okay, so what you would have to do is use a squared plus b squared equals c squared to find that missing side. So, so this is B. So B is equal to 5. C is the hypotenuse, so that is 10. And A is what we don't know. We don't know the side opposite angle A. So we're going to work out A squared plus 25 is equal to 100. Okay, so you can subtract 25 from both sides. You can do it in your head if you want to. So that's A squared equals 75. Then you can do the square root of both sides to get A equals square root of 75. And what you learn how to do in college algebra generally, or in just an intermediate algebra class, is how to reduce those radicals. So the reason I break it up into 25 and 3 is because 25 is a perfect square, and that can come out of the radical. So I best write that as 5 times the square root of 3. Okay, so now what I know is I know all 3 sides of that right triangle. And what I'm going to do is simply apply the definition. Okay, so I'm looking at sine of A. Okay, what you do on that is you just do the opposite, which is the 5 root 3 over the hypotenuse. So this would end up just being 5 root 3 over 10. You could reduce the 5/10 to a half, so you would get square root of 3 over 2 would be what that is. So that's just opposite over hypotenuse. Okay, if you do tangent of A, tangent is opposite, which is 5 root 3 over adjacent, which is 5. So you got opposite and you got adjacent. Opposite's on the other side of the triangle. Adjacent means next to. The 5s would cross out. That would give you square root of 3. Okay. Okay, now we're doing cosine of B. So now we're focusing on angle B. So pay attention to what the angle is. So adjacent B would be 5 root 3. The hypotenuse would be 10. Again, you can reduce that fraction, reduce the 5/10 to a half. You would get square root of 3 over 2. Okay? And then you're doing the cotangent of B. Look at B. The adjacent is 5 root 3. The side opposite B is 5. The 5's cross out, so that gives square root of 3. Okay, like that. Okay, and then you go to the secant. The secant of A, you're looking at angle A, so the secant would be the hypotenuse, which is 10, over the side adjacent. So adjacent A is 5, so your secant is going to be 10 over 5, which reduces to 2. So that would be the value of the secant. Okay, cosecant, you do the hypotenuse, which is 10. We're looking at angle B, so opposite angle B is 5, so 10 over 5 is 2. Now those, you're just looking at the definition, the SOHCAHTOA, and you have to know how to apply that to some right triangle. Okay, we're not doing anything with that yet. We just want to know how to take a right triangle and give the values of the 6 trig functions. Okay, so you want to make sure that you have the opposite, the SOHCAHTOA definitions of the trig functions to apply this kind of problem. Okay, anybody have a question? Okay, we're good. John, you good? Tristan, you good? Jordan, you everybody out there okay? Okay. All right. So now we'll kind of get into this, and then I'll, try to finish this up, and then we can work on the graphing here a little bit. This one is just graphing an angle and finding the sides and everything. Okay, so the initial side is always the positive x-axis. If you write an angle in standard form, you always start at the positive x-axis. And what you would do on this is every time, if it's negative, you know that you're going clockwise. And every time that you go through one lap, that will be negative 360 degrees. Okay, well, if you go another lap, then you're at negative 720. So you would have to show that you are going 2 laps. You have to show that rotation on there. You have to do that for that. Now what you would do is you would have to just figure out, okay, what's the distance between negative 930 and 720? So if you subtract negative 720, you get negative 930 plus 720. And when you do this, well, you just do 930 minus 720, which would be 210 degrees. So you end up with an extra negative 210. Okay, so that means that now what you need to do is just kind of count this out. That would be 90, 180, and then this would end up being 270. So you're kind of in here is where that negative 210 is. So negative 90, negative 180, and then somewhere over here. So then you just kind of estimate that, and that will be the terminal side. So you got to make sure that you have the initial side, and then you have the terminal side, and make sure that you are doing that rotation to show me which direction you're going. You have to have this arrow here too. A lot of times students leave that arrow off, and then if you leave that off, I don't know which direction you're going in. So make sure that you have that there. Okay. All right. Smallest positive coterminal angle. Well, what you can do on this is just keep adding 360 to it until you get a positive number. So if you did like I did over here, if you do negative 930 plus 720, when you do that, that gave you negative 210 degrees. We did that previously. Now if you just add 360 to it one more time, then you'll get the smallest angle that is coterminal to negative 930. Coterminal just means they have the same measure. They have the same initial and the same terminal side. So you could do 360 minus 210, so that would give you 150 degrees. So that was one of the first things that we looked at this semester, was how to draw angles and how to determine coterminal angles. Okay, all right. So you want to make sure that you know how to do that. Okay, now let's focus a little bit on the graphing next here. And the graphing, there's kind of different techniques for the different trig functions. The first thing that you want to do on this is this number 12, you have 2 sine of 1/2 x minus 3. You want to identify all these things in here. So this is the amplitude. The amplitude is the number in front of the sine or cosine. So that's easy enough. That's 2. Okay. The period, we have a formula, and the formula is 2 pi over b. B is the number in front of x. So you're going to do 2 pi over 1/2, and that's really 2 pi divided by 1/2. So that will be 2 pi times 2 over 1. So that's 4 pi. Okay, so your period is going to be 4 pi. Okay, that's how you do an amplitude and a period of a sine or a cosine. We're focusing on just the sine and cosine to begin with here. Okay, the increment will tell you how to do your x-axis. The increment is always figured out by doing the period divided by 4. The reason you're dividing it by 4 is a sine. All trig functions have 5 key points. So you're kind of finding you're basically evening that out by 4 spaces. So you take the period, which is 4 pi, you divide that by 4, the increment is pi. And that's how we're going to end up doing our x-axis then. Okay, so we've got that. And now what you're doing is I'm asking you to graph from negative 4 pi to 4 pi. So the increment means just count by pi. So you'd have 1 pi, then you would have 2 pi, then 3 pi, and then 4 pi. And then do your negatives. You would have negative pi, negative 2 pi, negative 3 pi, and negative 4 pi. So once you get the period and increment, that will tell you how to set up your x-axis. Okay, so that's real important. And that the methodology of finding the increment's the same for all 6 trig functions. You take the period and divide it by 4. Okay, the other thing we have in this problem is this is taking you down 3. That's the vertical translation. So that is going to be down 3. All right, now my goal on this problem is to show you how to do this pretty quickly and easily in maybe 2 steps. Okay, so this is what I recommend you do. Okay, you want to make sure that you know how the graph of y equals sine x is. That's helpful to have that memorized, just the graph of y equals sine x. So I'm going to go ahead and I'm going to, use some y values. I'm going to go up maybe to 5 and then down to negative 5. Okay, and you kind of figure that out. You can figure out the range of this if you want to. So you can do that. So this is what you really want to memorize. If you're doing the sine x, and what I'm really doing here is I'm going to do the graph of y equals sine of 1/2 x. And while we're at it, we might as well just go ahead and throw in the amplitude and do the graph of y equals 2 sine of 1/2 x. So we don't have a phase shift, but we do have a down transformation. So this is kind of the way that I look at this in one step. Okay, the sine starts at 0, 0. Okay, that's your first place. Then it will go to its maximum. However, since the amplitude is 2 on this problem, that's going to no longer be at 1, it's going to be at 2. Okay, then you go back to the x-axis. Then you go to your minimum. Okay, it's not going to be -1. The amplitude of 2 moves that to -2, like that. So that's kind of how one period of 2 sine of 1/2 x is. The 1/2 x, when you figure out the increment, you're figuring out where those key points are. Okay, a sine has 5 key points. It has the beginning, the maximum, the midpoint, the minimum, and the end point. And then from here, you just kind of sketch in the rest of them that go through that same cycle. Okay, so you want to do that. Okay, you can do that part in your head. All right, now all we have to do on this now is we've got the graph of this part right here. We have the graph of 2 sine 1/2 x. That's going to take every point down 3. So now to get your final graph, you just need to take every point down 3. So this is 0, has a y value of 0. That's going to go down there. Okay, that will end up being at that point. Same thing here, just go down. This is at 2, so go down 3 to end up at -1, and so forth. Just take each point down 3. This point right here would be -2. -2 minus 3 is -5. And then this point right here will go down 3 like that. So now when you're putting this together, that would be how one period of the final graph looks like. And then the same from here. Just take each point, move it down 3, and then you've got an accurate graph of your function. Okay, so that's how I approach a sine wave. That's also how I do a cosine. Okay, you kind of work inside out. You want to do this part right here all together if you can, and then just do that up-down thing at the end. Okay, the increment figures out where the key points are. The 2, the amplitude, it just stretches the waves. Okay, does that. And then at the end, you can do the down 3. Okay, the other thing I want to mention on this is now you're not going to be allowed to use a calculator when you're graphing, because you have to learn, if you're going to understand graphing of trig functions, you have to do it by hand. Okay, if you just put this in your graphing calculator, you'll get a beautiful graph, but you won't really learn anything about graphing. And that's what we're trying to accomplish here. So one other thing that's worth noting is you can check your answers on this. If you want to check answers, you can just pick a couple of things and see if they work. Okay, for instance, let's just check pi. So if I plug it in, if I do 2 sine of 1/2 times pi minus 3. Well, this is what's basically going to happen. You're going to have 2 sine of pi over 2 minus 3. You would look at your unit circle that we created on the first page, and you would find at pi over 2, you're at the point 0, 1. The sine is the y value, so this would be 2 times 1 minus 3, so that would be -1. And notice that that point has a y value of -1. So you can check as many points as you want to. I usually recommend that you just do maybe 2 of them. So let's do 2 pi. So you have 2 sine 1/2 times 2 pi minus 3. Okay, well, the 2's cross out, so you're really doing 2 sine of pi minus 3. If you're at pi radians, which is 180 degrees, you're at the point -1, 0. The sign is the y value, so you'll get 2 times 0 minus 3, so you get -3. Notice that that matches up. Okay, and I mean, sometimes students, when they learn how to graph, they like to just plug the x values in and calculate. You can do it that way if you want to. You could individually plug in 3 pi, 4 pi into the entire function if you want to. That doesn't really help you learn how the transformations work, but it'll get you the points. Okay, so that's how I like to teach how to do a sine and cosine, is by using this technique. Okay, does anybody have any question, anything I need to clarify on that? Okay. All right, now let's kind of look at there's a cotangent and then there's a tangent down here. Sine and cosine are kind of done the same way, and cotangent and tangent are done the same way. Okay. And the way this works is kind of like this. Okay, first of all, when you have a unit circle, the key points are going to be these points right here. Now let me just kind of create what's relative to these two problems. Okay, you got 0 radians, you got pi over 2 radians, you have the point 0, 1. Pi radians, you have the point -1, 0. 3 pi over 2 radians, you have the point 0, -1. Okay, like that. So here's what you have to know. If you're doing a cotangent of theta is x over y. The best way to learn any math, but in particularly trigonometry, is to be able to figure stuff out just based on definitions. So basically, the cotangent is undefined when y is 0. So y is 0 at these two locations. So one thing that you can figure out from the unit circle is the cotangent theta is undefined at x equals 0 radians and pi radians, and then it'll just go on with a pattern. Then it'll be 2 pi, 3 pi, and so forth. Okay, it's just going to be where y is 0. Okay, so the way that we're going to, and the reason I'm going over that is that will help you figure out the vertical asymptotes. Okay, you got to be careful on this. Now, the tangent and cotangent, the period is pi over b. Okay, the other trig functions are 2 pi over b, so you have to make sure that you know that. Okay, so the b value is 4, so the period would be pi over 4. So that's going to give you your period. Just take pi divided by the number in front of x. That's how you find the period. The increment, you always take the period, and you divide that by 4, and that will tell you where the special points are on the x-axis. So this is going to be pi over 4 times 1/4, so that will be pi over 16. So that is how you're going to increment that then. Okay, so I'm going to go ahead and we're going to set up our x-axis now. And I'm going to count this like this: 1 pi over 16, 2 pi over 16, 3 pi over 16, 4 pi over 16, and so forth. You just kind of go like that. So, and you reduce the fraction. So the first place I'm going to use is pi over 16. The second place is 2 pi over 16, but you want to reduce that to pi over 8. Then you've got 3 pi over 16. And then 4 pi over 16 reduces down to pi over 4. Those are going to be the places where you have your special points. And then you want to do this like this. So this is negative pi over 16, negative pi over 8, negative 3 pi over 16, and then negative pi over 4 like that. Okay? So you got everything set up. Okay, like that. You guys understand what I'm doing so far? Okay? That increment is incredibly important because it'll tell you where the special points are. Okay? Okay, so now what you want to do is you want to find an asymptote. Okay, so we're going to find the vertical asymptotes. Now, this is what you basically do. You take what's called the argument. The argument is whatever you're doing the cotangent of, or whatever you're doing the trig function of. And you're going to do two things. We're going to set 4x equal to 0. The reason we're setting it to 0 is because the cotangent is undefined at 0. Then we're going to do 4x equals pi. Why? Because that's another place where it's undefined. You can just pick two of those things, and then you'll find where two of your vertical asymptotes are. Okay, so this equation here I can divide by 4. That will give x equals 0. So what we would have is when x is 0, we need to make sure that we draw a vertical asymptote there. Okay, do the same thing over here. Solve this equation. You're going to get x equals pi over 4. So that's the next place. Now you can also do this, guys. I mean, you've already got your increment. All you got to do is count to 5 to find the next one. So 1, 2, 3, 4, 5. That next asymptote's going to be there. Okay, and then you can do this way. Just count to 5. Start here. 1, 2, 3, 4, 5. Your other asymptote is negative pi over 4. Okay, so we got that. Okay. So what you want to do on this now, when you do an equation of a vertical asymptote, you can do this in one of two ways. You can either look for a pattern, or you can just do a formula. The formula for a vertical asymptote of a cotangent is going to be x equals, just pick your any asymptote you want to, but I'm going to pick the lowest one. I'm going to pick 0. And then the period of this, you're just going to do the period, which is pi over 4 times k. Okay, so you pick an asymptote plus pi over 4k, so you would have to say x equals 0 plus pi over 4k, and you have to say that k is an integer. Getting the asymptote equations is one of the things that students sometimes struggle with. There is a formula for cotangent and tangent. For cotangent and tangent, you just say x equals an asymptote plus the period times k. Because every time a period goes by, you get another asymptote. Okay, that's why I look at that. That's my first asymptote, then the period goes by, and then I get another one. Okay, and then k is just an integer, so you would have pi over 4, 2 pi over 4, 3 pi over 4, and so forth like that is where your asymptotes are. Okay, now the next thing you have to know is this right here. We're going to do a little bit of calculation here. We won't have to do too much though. Okay, so what you want to kind of have memorized is how a cotangent goes. A cotangent, and I'm just going to put these dots here. Halfway in the middle of the asymptote, you're intercepting the x-axis. Okay, this thing will be at 1, and then this thing over here will be at -1. Now, those things are going to transform themselves. But to start with, you can just kind of lightly pencil those things in. Okay, but what we're doing is we are graphing y equals 1/2 cotangent of 4x. So all that's going to do is these y values are going to get multiplied by 1/2. Okay, and again, you could plug pi over 16 in. You can plug pi over 8 in and work it out and use the unit circle to help you with that. Or you can just kind of do this. All you're doing is taking the y value of 1, the y value of 0 and -1, and you're multiplying by 1/2. Okay, and what that's doing is that's telling you where the new y values are. So what you would end up having is you would have this then. You would have, this would be 1/2. So this point goes to that point now. 1/2 times 0 is still 0, so that's still a valid point. You do 1/2 of -1, that's -1/2. So that point now goes there. Okay, and then you got it. Then you just sketch it in. It will approach the vertical asymptotes like this. That's a really accurate graph. And then you can do the second period. Just, get these points, transform these points the same way. then you'll have another period like that. Make sure that when you graph that, that you don't touch the asymptote, you just show that it's approaching. Okay, and that's how you would want to do a cotangent. If you haven't, that's not really an amplitude. All that's doing is that's affecting the y values. That's the idea. Okay, you guys got any questions on that? To me, what I find is students usually tell me that the graphs that are the most difficult are the tangent and cotangent. I don't know if that's true or not, but that's what the way it seems is students have a little bit more trouble with these graphs than they do sine, cosine, and even secant and cosecant. Okay. Any question on that?
So basically, the 4 is a horizontal stretch shrink.
Exactly.
Action.
Yeah. So like in college algebra, you learned that if you have a number inside the function, you were in my college algebra class, that really shrinks you this way, shrinks and stretches. That's what it is. And then the 1/2 is a vertical stretch shrink. So what's happening is that half is shrinking those values by a factor of a half. So all functions work the same way. Every function you ever graph works the same way. The same kind of stuff you learn in college algebra. Okay? All right. All right, well, let's do this tangent, and then that'll be all I'll have time for. And then I can post this video so you can refer to this. And if you want to come on Wednesday night, we can kind of work a little bit more with the graphs and kind of get this stuff finished up. Okay. Okay, so what we're going to do on this one is we have y equals negative tangent of 0.5x plus 1. Okay. The period is pi over b. So we're going to just do pi over 0.5. Okay, that's your b value right there. So your period, you're best to work this like this. Do pi divided by a half. Okay, because 0.5 is a half. Okay, so that would just be pi divided by a half. So that would be pi times 2. So the period is 2 pi. Okay, so if you're doing a tangent or cotangent, it's pi over b is how you get the period. The increment, you always take the period and divide by 4. So we take the period 2 pi, divide by 4. That will give us pi over 2. Okay, and what that's going to tell us is that would be the places on the x-axis where you have the special points. And then just count it out. You have pi over 2, 2 pi over 2. You're counting by the numerator, 3 pi over 2, 4 pi over 2. So you would end up having pi over 2, and then this would be pi, and then you would have 3 pi over 2, and then 4 pi over 2 would be 2 pi. And the way that I do these graphs, I do this on purpose. I want the increment, when you count it out, to end up taking you to the interval that I want you to graph on, okay, for simplicity. So over here we would have negative pi over 2, negative pi, negative 3 pi over 2, and then negative 2 pi like that. Okay, and then on our y-axis, we'll just do maybe 1 and 2, and we can adjust that if we need to. Okay, so we've got that. Okay.
Interrupt.
Go ahead.
On the test, are you going to give us the interval you want us to graph? Or are you going to expect us to figure out?
No, I'll give you the interval I want. I give you the interval I want you to graph on. What I'm saying is, I will make the problem up on purpose. So when you do the increment, you will end up at the endpoints of the interval I give you. That's what I'm saying.
Okay. I figured based upon everything we've done, I wanted to verify.
Yeah. Okay. All right. Now this one has a vertical translation that's up 1 now, and it also has a reflection, and I'll show you how you handle that. Okay. So here's what's a little bit different about a tangent. Okay. If you go to a unit circle, remember the tangent of theta is y over x. So you have to figure out where it's undefined. So you have to figure out where x is 0. So what you're going to find is when you're at pi over 2 radians, x is 0. So the tangent is undefined at pi over 2 radians. You also have this point right here, which is 0, -1. So you end up having, this would be negative pi over 2. Or you could name it as 3 pi over 2. So what you do to find a vertical asymptote, and this is the way I like to teach this. When you do your graph on a tangent and cotangent, find a vertical asymptote. And all you really got to do on this is this. You take the argument, which is 1/2 x, and you set that equal to an asymptote, to a place where the tangent's undefined. So we're going to do that. Okay? Now I'm going to solve this equation. So I'm going to multiply both sides by 2. And what that will give me is x equals pi is going to be where one of your vertical asymptotes is. Okay? So what I'm going to do is I'm going to put my vertical asymptote at pi. Now you can count to 5 to get the other one. So if I count this way, it would be 1, 2, 3, 4, 5. So the next asymptote is at negative pi. So once you find one asymptote, you can count to 5 points on the x-axis to figure out where the next one is. So you've got that. Okay. Then what you have to know is kind of like the cotangent. On a tangent, halfway in the middle of the asymptotes, you're going to have an x-intercept. This point right here will be up 1, and that point right there will be -1. Now we have to transform those points. So the second thing we're going to do is you're going to go back to the function. You're doing negative, that negative, and then you're going to do 1 plus 1. Okay, then you're going to do a negative of 0 plus 1. And then you're going to do a negative of -1 plus 1. Okay, now see, the thing on this is we've already done the tangent of 0.5x. When we do the tangent of 0.5x, we're going to get the 1 and the 0 and the -1. So we just need to factor in the reflection and the up 1 thing. So if you work this out, if x is 1, then that point's going to go to 0 because -1 plus 1 is 0. So that new point is right there. Okay. You do this. This one's going to be 1. So the 0 is going to move up to 1 like that. And then you do this next one. That's going to be 2 because you're doing -1 plus 1. So that point is going to move there. And then you can sketch this in. So you kind of had a reflection and you had everything got moved up 1. So when you're doing a graph of a tangent and cotangent, you're always going to adjust those y values of 0, 1, and -1. Those are kind of your key points. And then from here, you can just reason out what these are. That would be that point. That would be that point. So that would go like that. And then over here, the points would go like this. You can just kind of reason out the pattern. So that would be how that goes, is kind of like that. Okay, now if you want to do the equation of the vertical asymptote, when you do the equation of the vertical asymptote, you just say x equals, pick any vertical asymptote you want to. I just say pick the smallest one. And then it will be plus the period times k, where k is an integer. You can apply that formula if you want to. So our vertical asymptote would be x equals pi. I'm going to choose pi. If you choose negative pi, I don't care. That's fine. Plus the period. The period was 2 pi times k, and then you have to state that k is an integer. So what this is saying basically is your asymptotes are going to happen at pi, and then it would go to 3 pi and 5 pi and so forth. But the 2 pi, since the period's 2 pi, adding that on to the first asymptote gives you the next one. Okay, so that's how you can get the answer on that then. Okay, so that's something that you have to work on a little bit. Now, you have a written assignment 4 that I gave over spring break. And the reason I want you to do that before you do the test is so you can have a little practice with doing graphs by hand. You do it on My Math Lab, I'm serious, you won't learn how to graph. I mean, it's just the way a computer is. You got to, a lot of times on My Math Lab, the graphs are given as multiple choice, and you're going to learn it very well that way. Okay, so do the written assignment. The thing on the written assignment also is, before you turn that in, I would highly suggest that you use your graphing calculator to graph what you did by hand and see if it's the same. Okay, so that'll take care of that. You guys got any question about the tangent or cotangent, what I did?
No, sir.
Okay.
I think that was really helpful, actually, okay. Especially the graphing part.
Yeah, I think the graphing part, if you follow the procedure that I'm showing you and that I showed you on the videos that I made, I think it's a little simpler. That's in my opinion. Okay. You can learn how to do graphing in different ways, but these are some of the quicker procedural ways to learn how to graph. Okay. All right.
Yeah, thank you.
All right. So we'll go ahead and end here. I'll do the video.